Swayam Prabha. Digital India. Educated India.
Welcome to the tutorial on central difference method. As discussed already, central difference method is one of the techniques which is used for solving the differential equations. Basically, this is used as a method in finite difference techniques where we have forward difference as well as backward difference, but we will be discussing about central difference method in this tutorial. So, this central difference method is basically depends on this assumption that at time step t is equal to tau, we need to get or we need to know the values of ti plus 1 and ti or ti minus 1. So, u or the displacement at time step I will be calculated by using I plus 1 step and I minus 1 step. Similarly for velocity also. So, velocity, as we know, rate of change of displacement can be represented in this manner: ui plus 1 minus ui minus 1 by 2 delta t, and acceleration is represented in this manner: u dot I plus 1 by 2, that means half I plus 1 by 2, which is this half, or it can also be represented in terms of I also, where we have derivation like this. So, I plus half will give you I plus 1 minus ui by delta t, and u dot I minus 1 by 2 is equal to ui minus ui minus 1 by delta t. So, using these two, we have u double dot to be represented like this: u double dot I is equal to ui plus 1 minus 2 ui plus ui minus 1 by delta t whole square. So, this is how we represented u dot I and u double dot I. This has already been discussed in the lecture. So, we go with the algorithm which is used for calculating the displacement of a particular structure or the single degree of freedom system. This is the summary what we have to do in this algorithm. U dot 0 or I is equal to 0, the initial condition, can be obtained from using u1 and u minus 1 by 2 delta t, and similarly u double dot 0 will be calculated using u1 minus 2 u dot plus u minus 1 by delta t whole square. And in this calculation, one more important parameter or one more important step we need to calculate is u minus 1, because usually this algorithm will be used in calculating the displacement using any program, computer program. So, in computer programs, we don't have I minus 1 step. So, usually indexing will be starting either from 0 or minus 1. So, in order to calculate that, we need to initially calculate u minus 1. This is the condition where we need to calculate already much before. So, u minus 1 is calculated like this, and initial displacement and initial velocity are calculated in this manner at I is equal to 0. That means the first step, you have initial displacement and initial velocity equal to 0. That means this is completely a forced system, I mean to say forced and damped system, where the equation of motion is given by this mu double dot 0 or mu double dot plus cu dot plus ku is equal to p, where p is the external force. So, from this equation at time step I is equal to 0, u double dot 0 is given as p dot plus p naught plus cu dot naught plus ku naught by m. So, this is how we calculate the initial values. So, we will calculate or we will discuss about the algorithm which is required for calculating the response of the structure. So, as initial calculations are required, so initial calculations for acceleration u double dot 0 at I is equal to 0, we have p naught plus c u dot 0 plus k u dot u 0 by m. So, this is acceleration at time step I equal to 0, and u minus 1, which is the previous value from 0, u 0 minus delta t into u dot 0 plus delta t square by 2 u double dot 0, and k cap is an initial value which is almost constant for the particular problem, for the given problem. M is constant for a particular structure and C is constant, and delta T is constant time step for the force applied. and A is m by delta t square minus c by 2 delta t, and B is calculated as k minus 2m by delta t square. So with this initial values at time step I, P cap I is calculated as Pi minus A into Ui minus 1 minus B Ui, and Ui plus 1 is calculated as P cap I by K cap. So here the one important thing that we need to keep in mind is we are getting I plus 1th value at the time step I. So in indexing the time steps or the forcing frequencies, we need to take care of the index that has to be given in the computer program. So we get only I minus 1 values when we are calculating for I values. So u dot I, which is velocity, is calculated as ui plus 1 minus ui minus 1 by 2 delta, where velocity is calculated at time step I only. Only displacement we will get at I plus 1 step. So this has to be taken care when we are writing any computer program. And acceleration, similar to displacement, we have acceleration which is at time step I only. U double dot I is equal to u of I plus 1 minus 2 ui plus ui minus 1 by delta t whole square. So this is the algorithm that we have to follow. For this problem, we will be going through the different steps of the algorithm which we have discussed now. So idealize the shown building into a single degree of freedom system and determine the displacement time history of the structure for epicentral earthquake. So assume grade of concrete as M25 and the given details are slab thickness is 120 mm, floor to floor height is 3 meters, brick wall thickness, internal, external and parapet all are equal, which is equal to 230 mm, and height of parapet wall is 1 meter. So in this plan, we have equal size of columns which is equal to 230 mm. This is the size of column and beam. So 300 by 300 is the column size and beam size is 230 by 300. So each bay length is 5 meters. So as we have already discussed in week 7 tutorial, mass of each floor is calculated and mass of first and second floors is 176.69 into 10 to the power of 3 kg, and mass of the top floor alone is around 136.22 into 10 to the power of 6 kg. So all put together, what we are trying to do is we are calculating the mass of total structure wherever, even though it is a 3-story structure, even though this can be lumped as a 3-story structure as a multi-degree of freedom system, we are not concerned with a multi-degree of freedom system, we are converting it to a single degree of freedom system. So all the mass is lumped at the top floor only. So whatever force that is acting on the structure will be acted upon, assume it to be acting on the top floor. So total mass is lumped here and stiffness is lumped only in this section, whereas damping is also present here and mass is lumped here. So total mass, which is addition of 176.69 into 10 to the power of 3 kg and 136.22 into 10 to the power of 6 kg is added up, and finally the mass is calculated as 489.6 into 10 to the power of 3 kg. So similarly, we have stiffness of one column which is equal to Ks1 is equal to 12 EI by L cube, for which E is calculated as 5000 root FCK, 5000 root 25, which is already given value, which is obtained as to 25,000 Newton per mm square. I is BD cube by 12, which is equal to 300 by 300 column. So 300 into 300 cube by 12, which is coming around 675 into 10 to the power of 6. When you substitute E and I in calculating stiffness, we get around 7.5 into 10 to the power of 6 Newton per meter. So stiffness at each floor is similar, and we have 12 columns in the complete structure. So we are idealizing it as a single degree of freedom system. So we are calculating 12 into 7.5 into 10 to the power of 6, which is coming around 90 into 10 to the power of 6 Newton per meter. So from we got stiffness value and the mass value, which is already coming around m is equal to 489.6 kg. So using this mass and stiffness, we calculate natural frequency of the building, which is equal to root over k by m, which is calculated to be equal to 13.56 radians per second. So after completing calculation of natural frequency, we go upon calculating natural time period of the building, which is equal to 2 pi by omega n, which is coming around 0.46 seconds. Assuming 5% damping in the building, C is calculated, which is called damping, is calculated as 2m zeta omega n, where m is 4.89.6 into 10 to the power of 3, and zeta is calculated, zeta is 5%, so it is around 0.05. So 2 into 489.6 into 10 to the power of 3 into 0.05 into 13.56, that is equal to 663897.6 Newton second per meter. So epicentral earthquake is usually recorded for 32.5 seconds with a sampling frequency of 50 Hz. That is delta t, that is time stepping function. Time step is coming around 0.02 seconds. So the initial calculations at I is equal to 0, P naught is calculated as m into A naught, which is the acceleration that is coming from this earthquake. A0 is the first value, which is multiplied by the mass of the structure, is the induced force that is acting on the single degree of freedom system. P naught is calculated as 489.6 into 10 to the power of 3 into 0.0063, which is the value which was recorded, the first value of the record. So 3084.48 is P naught, where A naught is 0.0063 centimeter per second square. So this is the first value of P naught, and U double dot 0, this is the initial acceleration, which is equal to P naught plus C U dot 0 plus K U 0 by M, which is already discussed. So calculating this one, 3084.48 plus 663897.6 into 0, where we assumed U dot 0 as 0 and also U of 0 as 0. So these two values, initial conditions are 0. So initial conditions are calculated, initial conditions are assumed before we start the problem. So calculating this acceleration, initial acceleration, we got around 6.3 into 10 to the power of minus 3. So in calculating, as already discussed, in calculating U at 0, we need to calculate U minus 1, which is the imaginary value, using U0 minus delta t into U dot 0 plus delta t whole square by 2 U double dot 0. Now delta t is 0.02, the sampling frequency, and U dot 0 is 6.3 into 10 to the power of minus 3, which we got before. So calculating U minus 1, we get around 1.26 into 10 to the power of minus 6. This is displacement at minus 1 step, imaginary step. So K cap, which is a constant, is calculated as m by delta t square plus c by 2 delta t. So m we have calculated as 489600 by 0.02 square plus 663897.6 by 2 into 0.02, which is coming around 1.24 into 10 to the power of 9. Similarly, we have another constant, which is A, which is calculated as m by delta t square minus c by 2 into delta t, which is coming around 1.2074 into 10 to the power of 9. Similarly, B is calculated as k minus 2m by delta t, where k is 90 into 10 to the power of 6 minus 2 into 489600, which is the mass of the structure, by 0.02 square, which is coming around minus 2.358 into 10 to the power of 9. These three values are constant throughout the program or throughout the problem for specific to that problem. So after calculating the constant values, for ith step, P cap I is calculated in this manner: Pi minus A into Ui minus 1 minus B into Ui. That means we need Ui minus 1th value. So at I is equal to 0, that is the first step, P cap 0 is calculated as P0 minus A U minus 1 minus B U 0. So P cap 0 is 1762.6, which is P naught, which we have already calculated, minus 1.2074 into 10 to the power of 9, which is A value, which we got from the calculation, and 1.26 into 10 to the power of minus 6, which is U minus 1, which we have already calculated, minus B we got as minus 2.358 into 10 to the power of 9, and U0, which is the initial value, which is equal to 0, that we have assumed there. So finally we are getting a P cap 0 value as minus 174.738 into 10 to the power of 3. From this value, we will be calculating the displacement as Ui plus 1 is equal to P cap I by K cap. So Ui plus 1, where I is equal to 0, so we are calculating at U1, that is equal to P cap 0 by K cap, that is equal to P cap minus 174.738 into 10 to the power of 3 by 1.25 into 10 to the power of 9, which we got already, that which we got from the calculation which is made before. So u1 we got around minus 1.39 into 10 to the power of minus 4 meter. So now this is the first iteration. Similarly, we can do for some other iterations also. We can calculate at I is equal to 1, where p cap I is defined as pi minus a into ui minus 1 minus b into ui, and displacement is calculated at I plus 1 step. Ui plus 1 is equal to p cap I by k cap. So at time step I is equal to 0, t is given to us and the external force P is given to us, and finally displacement with the algorithm which we have discussed now, we will be getting ui plus 1, we will be getting at ui plus 1. So ui plus 1 is equal to p cap I by k cap. So using pi, that is p0 and t0, we will be getting at u1, but velocity we will be getting at u0 itself. So these are the initial calculations that we have already mentioned. So when in I is equal to 1, t value is given and p value is given, and u is obtained at 2. So u2 will be getting, and velocity using this u2 will be getting at velocity that is at 1 step, and u double dot 1. Similarly for second step, we have t2, p2, and u3 is obtained from this equation, and u dot 2 and u double dot 2 is obtained here. Similarly for all other steps. So as a summary, we can discuss this central difference method in case of any random signal, which is basically an earthquake force, and this has to be kept. The most important point that has to be kept is the indexing of the iterations. So when we are going for a computer program, we need to take care of the I minus 1th value and I plus 1th value. So displacement will be obtained for a one extra value, and whereas velocity and acceleration are obtained at the same value. So I number of steps or t number of steps will be there in velocity and acceleration, whereas displacement will have I plus 1 steps.